Okay, ladies and gentlemen, let's look at our objectives here, okay, and talk a little bit about how this relates to an assessment in which you will actually be scored, okay? This assessment was a formative assessment. You can see that I have circled places that are not correct, okay? We're going to go over that, but you're going to self-evaluate each one of your questions, okay? And they're going to be based on our objectives here. Now, when we're doing these reaction predictions, we have some things here, some I can statements. The very first one, I can predict the type of reaction. So, when you put single replacement reaction number 4, okay, when you put decomposition 2, when you identify what type of a reaction we have, that's 2 points. Okay? In order to do these reactions, we must know the formulas of the reactants. 2 points. So, did I write the correct formula for the reactants? We need to predict the products. Okay? It could be something as simple, okay, that I'm looking at is a non-metal oxide plus water yields what? Well, that yields an oxyacid, okay? So that's 2 points if you have the correct product. And then we have to also write the formula of that product. That's also 2 points. Finally, at the end, we must make sure that it is balanced. 2 points. Okay? So, I know we're all math wizards. 2 plus 2 plus 2 plus 2 plus 2 looks to me like 10 points. Okay? So, as we do this on a test, on a quiz, like you have coming up, okay, we do this on a quiz, each one of these are going to be worth 10 points, and I'm specifically looking for that breakdown. Now, once again, we're math wizards, right? Let's do some math. If I can do 6 out of the 10, that's 60%, right? That's a D minus. I hope we can get better than 6 out of 10. If we can get 8 out of 10, that's a B minus, 80%. Obviously, we're shooting for all 10 out of 10 points. Okay? Now, all of these next slides, okay, you've seen at one time or another. But this is dealing with the very first objective we just talked about, predicting the type of reaction. Okay? Here we got our little cartoon guys. For synthesis, little cartoon guys for guys and gals for decomposition. Okay? We got Mario and Luigi when they come together for a synthesis. We got Mickey and Minnie splitting up or decomposing. We said that during a single replacement, it's cutting in. Somebody's cutting into the dance. Okay? You're dancing with your girlfriend at the prom, then all of a sudden somebody else comes in and cuts in and wants to dance. Okay? So we are replacing one thing. Single replacement. Double replacement, okay? You're dancing with your friend, another buddy's dancing with her friend, and you just switch dance partners, okay? Double replacement, okay? And finally, here's the combustion one, okay? The combustion one. We got carbon and hydrogen right here, the two ladies, and this one's called the player, okay? Because you got your player here, which is oxygen. Your player there is oxygen, and oxygen is playing both. He's going out with both of those carbon and hydrogens, okay? So those are just our basic pictures, our cartoons of our first objective. Those you've seen before. They were on all the videos except for this last one here, okay? Now, let's look at the specific entrance slip that you just did. okay? Because you're going to evaluate, and I want you to write down your score, okay? We're going to correct it. You're going to correct it on there. So take out a different color than what you wrote. Everybody did it in pencil. Take out a pen, okay? You're going to self-evaluate your particular paper to see how you would have scored. Obviously, there are 40 on here, right? There are 4 questions, so it's going to be worth 40 points if it would have been scored. This isn't scored, okay? This is not going to be a grade. You're just going to evaluate how you would have done. Let's say this is the quiz. Now, phosphoric acid is heated. First of all, what type of a reaction is this? Okay, I have one reactant, correct? So where are you looking? Where are you looking? Go ahead and take out your packets, your activity series, your periodic tables, all that stuff. We need that stuff. Where are we looking? I've got one reactant. Trenton? That's a decomposition. Excellent. So we have a decomposition reaction, and we have to figure out what number of the decomp it is. So as I'm looking through my decomposition reactions, I can see that we have 6 different decomposition reactions. I'm looking, is it a metal carbonate? Is it a metal hydroxide, chlorate? None of those. Metallic acid. Oh, here we go. Bingo. What number? What number? Number 5. Good. Decomposition number 5, it is an oxy acid. Now, this was a very, very tough one, folks. A very, very tough one. H, phosphoric acid. The first thing I do, okay, I've identified for 2 points what it was. Decomposition number 5. Now I've got to be able to write the correct reactants, okay? I need to know my acid rules. IC, 1 or 3. What acid rule is this? Number 3. Good. Number 3. So I'm looking for phosphate. PO4 is a 3-, so I need 3 hydrogens. Okay? So phosphoric acid is H3PO4. 2 points there. Did you get it right? Did you get it right? Now, it says it's heated, so I need to put that triangle above the yields arrow. Okay? Put that triangle above the yields arrow. And phosphoric acid is going to break down or decompose. Now, here's the tough part with this particular one. Okay? I have H3PO4. And remember, I told you that on this type of reaction, we want to subtract water from it. Now, what's going to happen here is what I would logically think you could do, should do, okay? What you should do is I would think logically you would say that this is going to make HPO3, okay? Now, what actually happens, okay, what actually happens with this, okay, is that it doubles. So that H3PO4 is going to be H6P2O8. So when I subtract water, okay, when I subtract water, I'm going to get H4P2O7 and water. So those are my 2 products. Now, I assure you, folks, there will not be one this difficult, okay, this difficult on your test or quiz, okay? Question. Why did I double it? Because I had an odd amount of hydrogens, okay? I haven't balanced yet, okay? I haven't balanced it yet. Hang with me, but I've just made my products there. Okay, I've just made my products. You're right, though. Now I need to balance my chemical equation, And in order to do so, I'm going to have to put a 2 there. Okay? Now, one of the reasons that I put this on there is I wanted to see how you score it, because I didn't expect you to get this one right. Okay? I didn't expect you to get this one right just because of this, and this is what we call a diphosphoric acid right here. That is diphosphoric acid, but you've never seen that polyatomic ion. Okay? Go ahead and score yours out of 10, though. Everybody missed something on this, I know. Score yours out of 10, see what you would have got. Okay? And just write that score off to the left of the number. Okay? Off to your left of the number. Let's look at the second one. Let's look at here question number 2. Calcium oxide is reacted with cold water. Okay? What do you think? What do you think? What type of a reaction is that? Where are you leaning towards? Anyone? Anyone? Bueller? What? Synthesis. Okay? I'm also, yeah, I agree. I'm looking at the synthesis. Now, what number is synthesis? Because some people miss this one. Okay? I'm looking at synthesis, and 2 of my synthesis deal with water. Number 2 and number 3. Okay? Number 2 is dealing with a nonmetal oxide in water. Number 3 is dealing with an active metal in water. Okay? What do I have here? Do I have nonmetal or active metal? I have an active metal, so I'm dealing with single replacement number 3. Right there, 2 points, predicting the reaction. First objective. Okay? Now, I need to get my second objective, calcium oxide plus water. Did you get your 2 points for your reactants? Now, go ahead and read. Okay? Go ahead and read your 2 points for predicting the reaction. What does it say? What does it say for number 3? Right here. What's that say? Active metal oxide in water gives you what? A metal hydroxide. So my product is going to be a metal hydroxide. Well, what metal am I dealing with? Calcium. So I'm going to get calcium hydroxide. Calcium hydroxide. Calcium here is a 2 plus, hydroxide's a 1 minus, so I need 2 hydroxides. I need 2 hydroxides. Now, my 2 points there for predicting the reaction, writing the correct formula. Final thing, am I balanced? Am I balanced? Yes, I am. Okay, there's your last 2 points. Go ahead and score yours out of 10 there. Score it out of 10 there. My third reaction, potassium sulfide reacts with iron to nitrate. What type of a reaction do we have here? What do you think? Maggie, what do you think? What type of reaction are you looking at? A double replacement, excellent. Which type? Double replacement number 1. So you know you're going to need what for this one? What do we need for a double replacement 1? What's that called? The solubility chart. Good. The solubility chart. So I'm going to put that, tuck that away. I'm going to need that here in a bit. Okay? So I've correctly predicted double replacement number 1. There's 2 points. Potassium sulfide plus iron 2 nitrate. Did you write the correct formulas for our reactants? 2 points. Okay? 2 points. Now, on this particular one, remember on our on our double replacements here. On our double replacements here, we're going to flop the cations. So I'm going to get potassium nitrate, and I'm going to get iron 2 sulfide. Did I predict my reaction correct? Did I write my formula correct? Okay, 2 points there. Now, you could possibly miss one out of those 2 points, and some people did this on the entrance slip. You could miss one out of the 2 points if you didn't put the states. I'm not done yet, because for this to occur, I need certain states to happen. So I look at my solubility chart. What can you tell me about potassium nitrate? Is it soluble in water? Absolutely. So I need to put behind that AQ. If you don't have that AQ, you could miss a point. Okay? Look at iron 2 sulfide. Is it soluble in water? It is not. Okay? So you could put a down arrow here. You could put a parenthesis solid. You have to have those 2 things, because remember, for this double replacement reaction to occur, one product has to be soluble, one product has to be insoluble. Do we have that in this case? Absolutely. Absolutely. So this reaction will occur. Final thing. Last of my objectives, do I have a balanced chemical equation? Do I have a balanced chemical equation? I do not. I can see that I have 2 potassiums here, and I only have 1 here. So I need to balance my equation out, and it's going to work out perfect, because if I put a 2 there, I also balance up my nitrates right there. Now my equation's balanced. Go ahead and score that third problem there out of 10. Solomon? Isn't this a single replacement? No, because I have 2 compounds. On a single replacement, remember we have a compound and a metal. Okay, remember the lab yesterday? The lab yesterday where we added the metals to the compounds, to the solutions? That's single replacement. Okay, since I have 2 compounds, that's a double. We'll do that lab next week. All right? Now our last one here, okay, our last one here should be jumping off the paper at you. Why should it be jumping off the paper at you? Because of right there. What is bromine? What type of an element is bromine? Okay? Yeah, Medina? It's a diatomic. It's a super 7. What do we call bromine's group? The halogens. Good. So I've got a halogen here. That should be setting off on a little alarm. Your spidey senses. Okay? Your spidey senses. Because halogens are a special type of what? What type of a reaction? Do we deal with halogens in a special type? Anyone? This is why I guess we go around the world here. Austin, what type? No, what type of reaction am I dealing with here? Excellent. A single replacement, number 4, because remember, a halogen, okay, a halogen is a special type of a single replacement here. A halogen by a more active halogen. I told you what you're going to try to do, okay? Well, let's go ahead and write this. Bromine. I know bromine's a super 7. We just talked about that. A super 7, it's a halogen. Some people did not have that. Bromine reacting with sodium chloride. Now, I told a lot of you, actually, I told all of you, okay, when we talked about this, doing our review notes, I told all of you what you're going to try to do is take this bromine and replace sodium. And I saw some of you did this on this entrance slip. Will bromine try to replace sodium? No. Bromine, this is the special one. This is the special one. Bromine here is going to try to replace chlorine. Remember, we've got a special square on our activity series on that. Now, is bromine higher up than chlorine? No, it is not, is it? So will bromine replace chlorine? No. What do we got here? No reaction. Okay? No reaction. So, if you put no reaction here, do you have to worry about writing products? No, you get 2 points for that. Do you have to worry about balancing the equation? No, you get 2 points for that. Okay? You don't have to do those. It isn't there. Now, go ahead and score that one out of 10. Score that one out of 10. How are we doing? You can do your own assessment there. How would you have scored out of 40? Okay? And that's where you need to look and say, okay, where am I at? What do I need to look at more before my quiz coming up on Monday? Okay? Any questions for me? Claire? If you get the reactants wrong, you didn't write the correct formula?
That mean that, like, you get the balancing wrong too?
That could happen like that. Okay? You could be a direct. She's asking, hey, if you get the reactants wrong, you're probably going to balance it wrong too. No, that's a correct statement. Okay? So yeah, some of these things are tied together. Balancing's tied to everything, right? Balancing's tied to everything. Any other questions? Okay.